Hi, Remy here and welcome back. In this video, I'll be configuring Eddy Probe tap configuration. So let's start. First step is to make sure that the Klipper firmware is up to date, and for that, you need to go to your Klipper firmware interface. I use mainsail, so I'll go to Machine and Update Manager. And over here for Klipper firmware, you need to update. You have to click this update button and update the Klipper firmware. So this will update the firmware on the host. So this part over here, this will show that the version is on the latest version. So let's say if I click on update here now, and the latest version it shows as 646. So here instead of 641, it will show 646. If there is update for other tools, make sure you update that as well. It is not necessary, but it is good to have to the latest version. Once this update is done, and over here it shows that the latest version is the one which you want, you need to flash the firmware on the main toolhead board, that is the MCU. In my case, I'm using Menta M8P, so it has this microcontroller. Also on the host MCU, your CB, in my case it is CB1, your case might differ, and also the toolhead board. So make sure you update the Klipper firmware to the same version on all the MCUs. If you need to know how to update the Klipper version, you may refer to my previous videos. Link I'll mention in the description. I have videos how to update the printer main board and the SSD toolhead board as well, but not the host MCU. This host MCU update is very simple. I'll just show the steps over here in some time. Please note that the latest firmware, that is release 641, is just released while I was making this video. So that is why I have not updated to the latest version. Please note that the latest Klipper firmware commit ID is 641. In order to get the tap feature working, you need to be on commit ID 557 and above. With 557 commit ID, you need to do manual tap calibration. With 641 ID, you can do auto tap calibration. So once you check out with the latest commit ID or with 641, please note that the flash CAN bus method is changed. The old command was this one, which is Klipper lib can boot flash can pi. The new one is Klipper lib Katapult flash tool.py. The parameters remains the same. As mentioned earlier, video links to flash Klipper on the toolhead board and the main board will be in the description. To flash the host MCU, you need to follow these commands. Please note that this is not mandatory, but it is nice to have all the firmware to the same version. So first thing is go to your Klipper directory, then remove the config file, then issue make clean. This will clean the output directory, and then type make menu config, then change the microcontroller architecture to Linux processor. After that, save and exit. For that, you need to press the Q key on the keyboard, then enter. You will come to the prompt, and there you type make -J4. After that, type make flash. Once you do make flash, you need to restart or reboot the host. After you have flashed the toolhead board, the main board and the host MCU, reboot the printer. Please note, once you have updated to the commit ID 557 and above, the probe calibrate command isn't available. When I tried to configure Eddy TAP, I encountered two errors. The first one, CLKIN frequency too low, and the second one, insufficient lift. For the first error, that is frequency too low, I had not set any frequency for my toolhead board. The toolhead board, you need to set the frequency because for this toolhead board, the Eddy Probe sensor is connected. If the frequency is not correct, the tap won't work. So in my case, it was taking the default value, which is 12 megahertz. For this board, you need to set the frequency to 40 megahertz. This value I came to know when I posted this error, that is the CLK frequency too low. This error I posted on Klipper discourse forum, and a nice gentleman by name Timofey mentioned this to me over here. Once that was fixed, I faced the second error, that is insufficient lift. To resolve this, I had to set a negative value, that is -2, for position underscore min parameter in stepper Z configuration, that is here. This was not documented in Klipper, but with commit ID 646, that is with this one, the latest version, it's documented now. So which is here. You can see it says that you have to set the position underscore min colon to -1. In my case, I have set to -2. Now let's see the configuration. Please note the configuration must be defined in your printer.cfg file, either direct or include. First thing is to enable host underscore move. This section must be defined in order to get the set kinematic underscore position command available. Next, the probe or the Eddy probe configuration. The frequency, this is what we need to set. We have to define this in Hertz. The frequency must be 40 megahertz. Next, Z offset with the commit ID 588. The Z offset is renamed to descent underscore Z. So either you remove this or rename to descent underscore Z. So you have to take care of this parameter, that is frequency, and the descent underscore Z. Once these two are done, you can save and restart. So you go to save and restart button and then click on this. This will save the configuration and restart. Since now the frequency is updated from default 12 megahertz to 40 megahertz, I need to rerun this command. So I need to recalculate the drive current, also recalibrate the Eddy probe current sensor, and also do a temp compensation calibration. Please do not skip running these steps if you change the frequency, otherwise things will go wrong. Once recalibration is done, you can proceed for tap calibration. So for that, you need to execute probe eddy current tap calibrate with parameter tap equals guess as the first command, then next tap equals refine, and last tap equals verify. Once you execute this in the sequence in the same order, issue save and config. This will save the threshold value in printer.cfg file and restart the printer. So you will have a value something like this. Tap underscore threshold equals to some value. Do not copy this value. This is my value. Your value will differ. Now let's look at some macros. The first macro, that is reload Z offset from probe and set Z from probe. These two macros are defined in the Klipper website. I took these macros from there and modified to what I need. These two macros are required in order to get the Z homing and tap configuration working. Why it is required? Explanation is given in the Klipper website. I'll mention the link in the description. Please note, this macro requires the host underscore move feature enabled, otherwise it will throw an error. Now let's look at the first macro, that is reload Z offset from probe. This macro takes the current Z height, that is the Z position, and sets as the new kinematic position over here. So this is the only work this macro does. This macro is called from this macro, that is set Z from probe. So this macro will call this macro. Now let's look at set Z from probe macro. So in this macro, you set a default method. If not defined, it will set to tap. Then samples, number of samples to collect, samples tolerance, the variation in each sample, sample tolerance retry. If the variation is not within with this value, then how many times you need to retry. Then store the tap threshold value from the printer settings file. Then get the current safe Z height settings, that is the X and Y position. Then next it will home the printer if not home. After that it will move the Z or the bed, lower the bed to Z10 and take the tool head to safe Z home position. Once that is done, it will do the probe calibration. So it will do the tap threshold and get the value. After that, it will call the reload Z offset. So it will take the current Z position after tap and set that as the new Z kinematic value. After that, it will lower the bed to Z5. Next, we'll look at the calibrate Eddy TAP macro. So we'll look this macro. So this macro is basically the probe eddy current tap calibrate with parameter tap equals to guess, then tap equals refine, and tap equals verify. So all these three commands, it will run in sequence and then issue a safe config command. You don't need to have this macro, but you can put all the commands and execute at once. It will run the routine and do the tap calibration. This is required only for the first time or if you do some parameter changes. And last, we'll look at this macro, that is underscore z from probe. This is a wrapper. You can copy the G code macro from this macro and directly put it under the start print macro. You don't need to have, but I have done it this way because in my Z tilt adjust, the method I'm using is tap. So instead of using just the Eddy probe sensor, I'm using the tap to adjust the Z tilt. You can use the tap method for Z tilt and also for bad mesh. But in my routine, I'm using only for Z tilt, not for bad mesh. Bad mesh, I'm using rapid scan. Now let's look at this macro. So the first thing is it will lower the bed to Z10, then move the tool head to purge park location. Then it will warm up the nozzle. Do not make it too hot, otherwise it will start to ooze out the filament. Then run the nozzle wipe routine. After that, it will call the macro, that is the set Z from probe to calibrate the nozzle height. Then after that, it will move the tool head to purge park location. Now let's see the tap in action. So I have this small print which is 60 by 60 by 0.2 mm. So we'll print this. So now it's waiting for the bed heater. Once the bed is heated, it will wait for the secondary bed temperature, which has to reach around 55 degree. This is required to wait for the soak time. So I have a secondary bed temperature attached, so that I'm waiting as a soak time. Now the secondary bed temp has reached. Now the first routine of nozzle wipe will start. Now it's at the purge park location. So it will warm up the nozzle to 150 C and then do a wipe, and then after that it will do a tap calibration. So this will be the first tap calibration. Nozzle wipe is done now. Now it's doing the first tap calibration. Now it will do Z tilt adjust with mode tap. Next, bed mesh with rapid scan. And now it will go for the purge park location. And now the final tap calibration. Now back to the purge park location. After that, it will reach to the temperature, the print temperature. Then nozzle wipe, purge line, and then it will start to print. Z seems to be too close. I need to lift it slightly. So now nozzle has lifted or the bed has lowered by 0.1 mm. And the print is done now. And this is the close view, top side of the print and the bottom side of the print. As you have seen, I had to adjust the Z offset by 0.1 mm, that is increase the gap between the bed and the nozzle. So the bed, I need to lower it down. So for that, I need to set this value in start underscore print macro, so that next time I don't have to adjust it while printing. It will be set at the start of the print. So I'll go to machine, then config macro, then common, and then I have this start underscore print.cfg file. In this is the line of code that gets executed and set the Z offset depending on the type of filament. So in this case, it is PLA. So this particular line of codes will be executed. And this is the line which stores the Z offset from printer setting configuration macro. So the macro is called over here, this particular line. So this is the variable macro that all the variables are stored here related to the specific probe. Then over here, I'm calling that particular variable, getting its value, and it is being stored in this particular key. And this particular key is used down over here to set the Z offset. So this is the line. So now why I have done it like this? I have two types of probe. One is eddy current and other one is BL touch. Depending on the testing I do, I enable, disable the type of probe that I want. So let me show that. Go to config and then printer. Over here, if you see, I enable and disable the type of probe that I want. So here now BL touch is disabled and eddy current is enabled. Whichever I want, I uncomment and comment the one I need. So let me show the configuration over here. So we'll go to macro, the config file, and then eddy probe CFG file. In this, the very first line, I'm loading the macro variable or the macro file related to eddy current probe. Now same thing is there for BL touch. The very first line will load the macro related to BL touch. So we'll see the macro that is for eddy current. So go to config macro and then eddy current, eddy underscore current.cfg, and then this is the macro for the variable. In here I have this variable which I am using for PLA Z offset. So here I will set that 0.1 mm. So save this and then do a restart. Now let's see the start underscore print macro routine. So I'll go to machine, macro, common, and start print.cfg file. In this particular code I have already explained before. Then next, this is where the secondary bed wait time is. It will checks for the secondary bed temperature. Then this is the first call for the nozzle routine, wherein it will do the nozzle wipe, then tap calibration and set the Z offset. Why I have to do it here is because I'm using, if you look here, Z tilt, I'm using method tap. So the nozzle must be free from debris. So that is why I have to do the nozzle wipe, and then it will use the method tap to do or to adjust the Z tilt. After that, it will do bed mesh. This is rapid scan, so no need to do again cleanup and all. And then once bed mesh is done, it will again do a final nozzle cleanup. Over here, it will do the final nozzle cleanup and set the Z offset. Once that is done, it will wait for the normal routine like heating the nozzle temperature, set the offset, which I've shown earlier, and then it will start to print. Now let's see the tap threshold calibration process. Before that, we need to heat the bed to our normal printing temperature. I normally print PLA at 60, so we'll set this to 60 and wait for the bed temperature to reach at 60. Now that the bed has reached to 60, next step is to home the printer. So we'll click on home. So now homing is done. So we'll start the tap threshold calibration process. So we'll execute this command, probe eddy current tab calibrate space tab equals to guess. So this is the very first step. Next, we have to run the same command, but instead of guess, we need to change it to refine. And once that is done, we have to run the same command, but this time tab equals to verify. So once this is done, issue save underscore config command. So with this, it will save the configuration into your printer.cfg file. Since I have created a macro to do all the above steps into one, so I will execute that command, which is calibrate eddy underscore tap. By executing this macro, I'll be basically doing the guess, refine, verify, and save within one macro. So let's do that. First, it will do tap guess, then tap refine, then tap verify, and then save underscore config, and that will save and restart. So now the tap threshold has successfully configured, and that's all for this video, friends. If you like this video, do like, share, and subscribe. God bless and stay safe.